Welcome to video 9. Today we're going to be talking more about quadratic exam problems. So this first one here, the demon drop at Cedar Point in Ohio takes riders to the top of a tower and drops them 60 feet. A function that approximates this ride is h equals negative 16t squared plus 64t plus 60, where h is the height of the riders in feet and t is the time in seconds. To the nearest tenth, how many seconds does it take for the riders to hit the ground? So the key things out of this we should always highlight. What is most important is that we have this function representing that drop, and h is standing for the height in feet, and t is the time in seconds. Then I'm also going to highlight my rounding directions to the nearest tenth. We're looking for how many seconds. So that means I don't know the t value. If I don't know the t value, they must have given me the height. So does it take for them to hit the ground? Or I'm sure they're talking ground of the tracks. So that's going to be a height of 0. So I'm going to put 0 in place of the h, the height. So that's probably the most difficult part about these questions, is just knowing how to set them up. And we're looking for the nearest tenth, so that tells me that this is probably not going to be factorable, since they're saying I need to round. So I'm going to say it's either a better candidate for completing the square or quadratic formula. I'm going to use the quadratic formula to solve for t. So remember to have your reference sheet handy and identify the a, b, and c value first. Then you simply sub in the a, b, and c into a, b, and c in the formula. So we have t equals negative and then 64, and then you fill in the rest of the formula. So we have the plus or minus, the square root, using parentheses whenever we substitute the values in, and then all divided by 2 times the negative 16 here. Now the next step is to go ahead and simplify everything that we can simplify. So the negative 64 is going to become a negative 64, and then the plus minus. Then for all this information that's underneath the radical, all these numbers here, we're going to simplify this before we try the square root. In your calculator, you do this by using parentheses just like you see underneath this radical. So parentheses 64 close parentheses squared minus 4 parentheses negative 16 close parentheses 60 close parentheses. When you hit enter, you end up with 7,936. Now that's still under the radical because I have not taken the square root yet. And then in the denominator, we'll do 2 times negative 16 to get negative 32. Now normally we would try to see if we can simplify the number under the radical or take the square root of it. But my directions in the question said that we're going to round to the nearest tenth. So that means I'm going to need to put this in my calculator, and it's going to give me a long icky decimal, but I do want that decimal so that I can then round to the nearest tenth. So from here I'm going to split this into the two answers. Now, in order to get the correct answer, we have this negative 64 plus the square root of 7,936, all divided by negative 32. So we need to do one of a couple options. You can either simplify everything in the numerator, so just put this information in your calculator, hit enter, and then divide by negative 32. Or you can put all the information in the numerator in parentheses in order to make this happen first before the division. And the last option is to put all of this in your calculator as a fraction, and that might be different depending on what calculator you're using. So if you know how to put this in as a fraction, you can do that also. So one of those 3 ways needs to be done to simplify this answer. And when we do that, we get the answer t equals negative 0.7838821,814. Now, we would look to round, but if we're talking about time can't be a negative. So I'm going to actually reject this answer. X can't equal this, and that's because we have to reject the negative time. So then we'll try the bottom answer, the negative 64 minus the square root of 7,936, all divided by negative 32, using the same method you used up above. And you can rewind to that if you need instructions again. So then my t value here becomes
4.783882181. And since that is a positive time, that is a realistic answer. But now I need to go back to my question and see what they told me to do with my answer. They said I needed to round to the nearest tenth. So if I look here, tenths place, so I look at the 7 and then at the number next to it, the 8 here tells me I need to round up. So this rounds to 4.8 seconds. So my answer is 4 and 8 tenths seconds. Okay, let's try another one. This next question says we need to write an equation that defines w of x as a trinomial where w of x equals 2 minus x times 2x minus 1 plus 3x squared minus 48. Well, the directions tell us that we need to write this as a trinomial. So that means I need to only have 3 terms. Right now it's a polynomial with more than 3 terms. So in order to simplify this and make it look like a trinomial, we're going to start by multiplying. That's because order of operations would tell us first look to see if there's anything we can do in parentheses, but we can't simplify these parentheses at all because they're unlike terms. Next, we would look to multiply or divide from left to right. So we need to multiply the 2 minus x times the 2x minus 1. Now, since it's a binomial times a binomial, I'm going to start with an area model that shows the multiplication of these two binomials. So I drew my area model here to show the binomials being multiplied. So now let's fill in each cell of the area model. 2 times 2x becomes 4x, and then 2x times negative x becomes negative 2x squared because it's an x times an x. And then in the bottom left-hand side here, we have negative 1 times 2, and that becomes a negative 2. And then negative 1 times negative x becomes a positive x. And then we can go ahead and look for any like terms. So I found my like terms. They usually show up on the diagonals, and they do in this case, 4x and x. So I can put these together. I'm also going to write it in standard form though. So we started off with w of x, so I'm still going to write that w of x. Then I'm going to look for my highest exponent, and the squared is the highest one. So I'm going to start by writing that. So I have the negative 2x squared. Then the like terms, 4x plus 1x becomes 5x, and then I still have the minus 2. Now that was the binomial times the binomial, but if we look back at the question, I still had more to the question. It was also plus 3x squared, and then minus the 48. Now that I have written it all down, I can look for any like terms to show up because I still don't have a trinomial here. I'm getting closer, but I'm not there. So let's look for any like terms. The first ones that I see over here are the negative 2x squared plus 3x squared, so that becomes 1x squared, or we can just write it as x squared. We have 5x, and there are no other x's to combine with, so I'm just going to write that with the plus 5x. And continue looking for like terms, the negative 2 and the negative 48 combined to become negative 50. And now I can see that I do have 3 terms making this a trinomial, so I'm pretty confident that this is a good answer. The next question says we need to solve this for x when w of x equals 0. So that means that instead of being w of x equals, I'm going to substitute in 0 equals. Now that I've done that, we need to go ahead and solve for 0. So our options again are to factor, complete the square, or use the quadratic formula. Now since I've already shown you an example with a quadratic formula, I'm going to go ahead and try to factor this one. So we're going to start with the x and then the box. Now remember, this might look a little different depending on your teacher, but we all use the x to find the factors. It's just that the area model might be new to you. So let's fill this in by first identifying a, b, and c in our equation over here. So I encourage you at this point to go ahead and try to identify a, b, and c and pause the video so you can do that without just getting the answer from me. Equals 1, b equals 5, and c equals negative 50. Then we can fill in the x. So the top we have negative 50, and at the bottom we have 5. That's a times c for the top and then b for the bottom. So now we need to find the factors that have a product of negative 50 but add up to 5. Again, pause the video and see if you can find the factors. Okay, so the factors are 10 and negative 5. Now we can go ahead and rewrite the b term to split it to be those two. 0 equals x squared plus 10x minus 5x minus 50. Now it's ready for factor by grouping. The first two and the second two. Then the first two will go in my top row, so it's x squared and then the 10x. And then in the bottom, we put the negative 5x minus 50. So then we look for the GCF of the first two, so the x squared and the 10x. The greatest common factor here is an x, so that's what fills in this spot right here. Then ask yourself, okay, what times x is going to give me x squared? Or the alternative is to say, okay, well, x squared divided by x will give me what goes here. So what times x is x squared? That would be an x. Then what times x will give me the 10x? That would be a positive 10. And then what times x will give me the negative 5x? And that would be a negative 5. And then remember, always check the last one. So 10 times negative 5 is negative 50, so I'm confident in my two factors. So now I can rewrite the factor by grouping, rewrite these four terms as this binomial times this binomial. So 0 equals x plus 10 times the x minus 5. Now I'm ready for the t-chart to find out what the x values can be. So we set each factor equal to 0, and the reason for that is because if either of these factors are 0, 0 times anything will end up being an answer or product of 0. So that's why we set each of these equal to 0, then solve for x. So for here we would subtract 10 to both sides, and then our answer would be x equals negative 10, and then on the right hand side we would add 5 to both sides, and we would find 5 equals x. And those are our two answers, negative 10 and 5. The next question says that Tammy found the zeros of the function f of x to be negative 3 and 8. So when she says the zeros, that means that they already solved for the roots or the zeros. So I can write down for the function that the roots x values equal negative 3 and 8. And that's because it said that the zeros of the function f of x are negative 3 and 8. I now want to write down the quadratic equation that could represent her function f of x. So think for a second and pause the video to try to figure out, well, what can I do if I know what the roots are? How can I work backwards to then find the equation? Okay, well, my hint was that we needed to work backwards. So instead of having, like we did up above here, the values to look for these values, they're giving them to us. So we have to work backwards. So where did we get the x values from? Well, they came from the factors. So the factors were set equal to 0, not equal to a number. So let's change these. So instead of being equal to a number, they're equal to 0. So the way to do that would be to take this number and move it to the other side using inverse operations. So since it's a negative 3, I'm going to add 3 to both sides. Now the negative 3 and the positive 3 will cancel, so then I'll have it equal to 0, which is what I wanted it to be. So now I can see the x plus 3 equals 0, and this is all of these steps just working backwards. So it was a number, so we made it equal to 0. So where did that come from? It came from the factor. So now I can just put this in parentheses as the factor. Now we'll do the same thing for the x equals 8. So the first thing we did was add 3 on the other side. So in order to do this one, it's x equals 8. The 8 needs to go away, so we need to subtract 8 to both sides. Then 8 minus 8 will cancel, and we're left with x minus 8 equals 0. So again, if we look at, okay, well, the process, we're working backwards. Once it was equal to 0, where did that come from? It came from the two factors being set equal to 0. So now what's the factor then? Well, the factor would be this. So next to the x plus 3, I'm going to now write the x minus 8 as the second factor. So those are the two factors, and if we look up, that came from being set equal to 0, but what was it originally set equal to? Not 0, but if we're looking for an equation f of x, we're going to set it equal to f of x. So we can see that this would be the function that would represent these two answers. If I went into my calculator and put in y equals, because remember f of x is a fancy way of saying y equals, and then we subbed in the x plus 3 and the x minus 8 in parentheses just the way it shows up here, we would go to the table and see that the roots are at an x value of negative 3 and an x value of 8. Now, the one last thing I'm going to show you what you could do with this to go one step further and simplify it is we could use the area model to then figure out what the quadratic is. So off to the side, I'm writing the x plus 3 and the x minus 8 being multiplied. And then we can fill in the area model. So x times x would give me x squared, and then the x times the 3 would give me a 3x, and then in the bottom left cell here, negative 8 times x would give me a negative 8x, and then negative 8 times 3 would give me negative 24. Then when I look at my diagonals, I can see that there are like terms. The 3x and negative 8x combined. So then I can rewrite my equation as f of x equals x squared minus the 5x minus the 24. Now these both are correct answers, so either one is okay. The reason I took you through simplifying is because if it's a multiple choice answer, what you originally came up with might not be one of the choices. So then you would have to know that you can go one step further and simplify to find your answer. So I'm just boxing both answers so you know either one is okay. Now that I've taken you through some examples, your assignment is to finish the remaining questions on this sheet. Have a good night.